Hey, sixth graders! Today we are going to look at modeling a geological process. So yes, in the last lesson, you should have read about a model that was created to look at geological process on Venus. And now today we are going to look at creating our own models and what that means. So you read about the scientist who found novae on Venus and tried to figure out what was happening, and they were trying to gather evidence to help answer a certain question, a particular question. And it was really important that you were able to look at that and kind of say, hey, were they able to answer their question? Were they not able to answer their question? And the question we were looking at or the question we were thinking about was what the temperature and if the temperature played a role in how this novae formed on Venus. So it's important that we reread text, that we review text in order to become better readers, to become better scientists, and to better understand difficult things that we're looking at. So today you are going to start by rereading or reviewing the text that we read yesterday. So if you have not already done that, go ahead and grab one of the articles from the purple bin. Remember, you have three options. You have your circle, your square, and your diamond, and you can pick the one that best suits your needs. And then we're going to investigate this question: how do models help scientists answer questions? So we're going to really look at how we can use models to help us understand what we are working at, what questions we have, and what questions we are asking. So a model, if you don't remember, is an object diagram or computer program that helps us understand something by making it simpler. So we could use computer models, which are like digital, and then we could create actual physical models. We could create diagrams. We could use things, objects, in order to create different models or to look at models. The shapes that were very similar to the novae formed in the model that was in the article is evidence that his ideas were accurate. So he was able to create a model, then look at the pictures of Venus and compare them and say, oh, these are really similar. So he thinks that his ideas, or he's using this as evidence to support that the ideas were correct or accurate. So we can look at this claim evidence reasoning, and the claim was that a thinner crust and higher surface temperature might allow melted rock to push up towards the surface, forming the novae. The evidence is that the model matched his results of the novae on Venus, and then he can explain, so he can explain his reasoning or give a reasoning that there are novae on Venus, but they're not on Earth, and because his evidence says that, hey, we created this model, we found these novae, and that the Venus has a thinner crust and a higher surface temperature than Earth. So that means that they can form on Venus, but they cannot form on Earth. So the key concept that we are looking at is scientists can use models to test their ideas to give evidence about processes in the natural world that are difficult to observe. So things that we can't necessarily observe without taking a really long period of time or looking at a time lapse, we could create models to make things move faster or slower in order to observe things that happen outside in our natural world. It's just really cool. So today you are going to be looking at the geological processes using a model and creating a model, and we are going to gather evidence about whether the water that we were looking at on Mars, so what geological process formed the channel on Mars. So we're going to start with a water model, and we are going to see if water could have formed that channel on Mars, and then we're going to look at a lava model and see if lava could have formed it. So we'll compare water and lava. So we'll use a physical model, so that's something that we're actually going to hands-on, we're going to touch, to test these ideas that landforms remain after flowing water formed stops flowing. So when the water stops flowing, do we still have landforms? Do we still see mountains? Do we see rivers? Do we see channels? What do we see after the water stops flowing? You're going to create a model that looks a little bit like this. We have it set up a little bit different in our classroom, but we're going to think about what are the parts of the model, what do they represent in the geological process on Earth, and what do they represent in our geological process on Mars, and what each piece of our model is. I'm going to let you think about that. In our model, we have water, we have sand, and I want you to think about what do they represent as far as our spheres go? So we talked about all of the spheres, the interacting part of our systems that work together. So what parts of our spheres are each of these pieces of our model? And we're going to think, I want you to think about, what do you think this model is going to show us based on the questions that we're asking and the materials that we have? While you're in your lab, you're going to be recording some answers in your digital assignment. So you're going to kind of draw some pictures here about what you're thinking and record your observations. And if at any time you're feeling confused, you're not really sure what to do, you can come back to this presentation and watch this video. I'm not going to play the video here because I want you to explore and investigate on your own, but if for some reason you have some questions still, this presentation is linked in the assignment up above, and you can open up the presentation and then you can come watch this video. Oh, it's going to play. Sorry. So I want you to think about while you're working on this, what did you notice about the landforms after the water stopped? Were there landforms? Were there not landforms? Did your evidence support your predictions, or was it not supported? Do you think you have enough evidence to answer these questions about whether this flowing water model created the landform on Mars? And then our last key concept is landforms can provide evidence about the past because they may or may not remain after the geological process that formed them has stopped happening. Remember that we are trying to look at how do models help scientists answer questions. So I really want you to use your model, think about your model, and utilize all the things that you have there. And that is our lesson. And as you get to work here, remember that you can use your models to test ideas. We're going to look for channels. And remember, hoy es un buen día para estudiar.